Hey kids, do your best on the test. Let's get started.
Here we are asked to solve for x, and that's the segment here. We do know that the radius is 26, so this guy is 26. Because of the diameter that is perpendicular to this chord, we know that this is 10. So then we use the Pythagorean theorem to solve for x. Minus 10 squared both sides. 26 squared minus 10 squared, 576. The square root of 576, x is 24. For this scenario, you want to identify where is the vertex of that angle that you want to look for. This angle, the vertex is on the circle, so it will be half 64, which is 32. If the vertex were on the center, that would be 64. But since the vertex is on the circle, it will be half of 64. Now we're asked to look for y, and y will be the same as this angle because of these two tick marks. The full thing is 360, so subtract what we currently see. That would be 296. Split into half, that would be 148. So y would equal 148. And this would be 148 also. Together, they would be 360. When we have a quadrilateral inside a circle, we know that these guys are supplementary. So 8y plus 68 would equal 180. 12. Y is 14. On the other hand, the other two opposite angles would also be supplementary. So 6x plus 8 plus 4x plus 2 would equal to 180. 10x plus 10 equals 180. 10x equals 170. X is 17. In this scenario, you'd want to remember that the two outside arcs would equal these two vertical angles. So 30 plus 172 would equal x plus x. This is 202, 2x. X is 101. And if this is 101, then the supplementary angle is 79, because two of them should equal 180. When all the segments are inside the circle and none of them are outside, then this would be the part times part equal part times part. So 8 times 3x minus 2 would equal 4 times 5x. 24x minus 16 equals 20x. Subtract x and add 16. X equals 4. Here the segments are outside and they are touching the circle only in one spot, so they're both tangent lines meeting on an outside point. So 3x minus 24 equals 7x minus 6. Minus 7 both sides, plus 24 both sides. X is 3. In this scenario, there are segments outside of the circle. So this is the the whole part. That would be 6 plus x times the external part, which is just 6. Whole part is 9. External part would be 8. So 36 plus 6x equals 72. 6x equals 36. X is 6. In this scenario, we're asked to look for this segment. Notice that the segment is a radius. Therefore, this portion would be the same, and it would also be x. Now we use the Pythagorean theorem, only this h would be 4 plus x. I'm going to write this as x plus 4. And this hypotenuse squared equals x squared plus 12 squared. Here we need to FOIL them. So the first one is x squared plus 4x plus 4x plus 16. Okay. So this is x squared plus 8x plus 16 equals x squared plus 144. We subtract x squared to both sides. We subtract 16 to both sides. Leaves us with x equals 16. In this scenario, there are segments outside of the circle, so this would also be whole times the external, except that was a tangent, so 12 is the whole and 12 is the external. And the other segment would be whole is x plus 8, external is just 8. 144, 8x plus 64. Minus 64 on both sides, that's 80 equals 8x. X is 10. That is the end of our warm-up. Go ahead and put everything away except for something to write with and your calculator. Don't forget to read the questions carefully and show your work.